This is the second part of our LISP chapter. We are going to talk in this session about why we will need LISP. We are going to include LISP advantages and LISP adoption. Let's talk about the advantages of LISP. First of all, scalability. With traditional routing IP protocols, when you add more routers to your topology, that implies that individual routers will have to use more CPU resources and more memory resources in order to calculate the increasingly growing routing tables. That does not happen with LISP, because with LISP, the complete routing information base is stored in a specific centralized devices that liberates individual routers from the burden of having to compute large routing tables for the complete topology. That is why LISP scales better than traditional routing protocols. Let's talk about the next advantage of LISP, which is traffic engineering. LISP provides two parameters in order to perform traffic engineering: priority and weight. Let's illustrate them using an example. Let's say that we have this endpoint ID here that is connected to the LISP domain through this router. Notice that this router has two wide area network interfaces. We can configure these wide area network interfaces with a priority. The one that has the higher priority will become the primary interface, and the other will become the secondary interface. All the traffic will get moved through the primary interface in this example. Now, if we configure the same priority for both interfaces, they will behave in an active manner. And then we could use the weight parameter in order to load balance across these two active interfaces. So we can reach or try to reach a 50-50 load balance, 80-20 load balance, and so on. Let's talk about the next advantage of LISP. That is probably one of the most important advantages of LISP, which is virtualization. This means that the support for VRFs is built in natively within the LISP routing protocol. So we are not talking here about VRF Lite. We are talking here about full-blown support for VRFs within the protocols. This means that you no longer have to build data path virtualization between routers. LISP will be in charge of doing that automatically for you. Notice that when configuring VRFs within LISP, we are going to call them instances. There are two ways to configure virtualization within LISP: the share mode and the parallel mode. Let's illustrate the share mode first. With the share mode, we can have EIDs that belong to a particular VRF. So we can have this EID that belongs to the red VRF or red instance. And we can have, for instance, this other endpoint ID that belongs to a different VRF. Let's say that this belongs to the blue VRF or blue instance. And for the share mode, the RLOCs that we are going to use to reach these endpoints IDs that belongs to different VRFs will use the same addressing domain. This means that we are not going to virtualize the RLOCs. We are only going to virtualize the endpoints IDs. Let's illustrate how the parallel mode works. With the parallel mode, we can have this endpoint ID that belongs to the blue VRF or blue instance, but at the same time, we can assign these RLOCs to the blue VRF or blue instance. That means that we are also being able to virtualize the RLOC domain. And we can have other VRFs as well. So for instance, we can have this endpoint ID that belongs to a red VRF or red instance, but we can also assign R-logs to these VRFs. So we will have some R-logs that are assigned to a different VRF. So with the parallel mode, we are virtualizing the endpoints IDs, and we are also virtualizing the R-log domain. Let's talk about how LISP has been adopted within the networking industry. Originally, LISP was thought as a way to reduce large routing tables mostly for carrier networks. It was thought mainly to be used on wide area network carrier environment. However, to be honest, LISP has had a really slow adoption for production networks. And that was a fact until Cisco chose it as a basis for its enterprise fabric product. So Cisco has modified LISP in order to be used on a local area network enterprise environment for its fabric solution. So just be aware that knowing LISP is important nowadays because Cisco is using it as the control plane protocol for its fabric product. This is a summary of what we saw in this session. First, we talked about the advantages of using LISP. For instance, how LISP scales better than traditional routing protocols, the traffic engineering parameters that LISP offers, such as priority and weight, and how LISP supports virtualization natively, and what virtualization models we can use within LISP. We have the shared model and the parallel model. Finally, we talked about how LISP has been adopted as a protocol within the networking industry and the importance that it has now because it is an important part of the new Cisco Fabric solution.